Hello all, welcome to day 8. Hope you're having a wonderful day. So for this unit, we're starting our brand new unit, unit 2 in your Math 154. It's your modeling unit. So to start you out, we're going to talk about what sequences are and then move into those various patterns. So what a sequence is it's some type of pattern, it's some type of numbers, figures, or objects that are in some order. Now, how we do them in math is we tie them together with some type of rule or a set of rules that's going to give us the next one. And that rule could be we're going to add 2 every time, we're going to divide by 2, we're going to add 3, then 4, then 5, but there's some sort of consistent rule every time with it. So we need to know a couple different notations as we go into this unit. And the first one is this idea of your P is your term number. So PO is your initial value, and it's actually the first term in your sequence. P2 then is after 1, 2 iterations. So these are your number of iterations. So it's actually going to be the third term. So whatever your P subscript is, you're actually one more term than what we think. So if we have the sequence, a simple 1, 2, 3, for example, PO is the 1, it's the first term. P1 is the 2, it's the second term. P2 is the 3, it's the third term. So P2 represents the third term, etc. So kind of just note that. So if you're being asked for P2, you're not being asked for the second term. You're being asked for 1, 2 iterations of the sequence. So again, just note that. So if I'm being asked for P5, for example, I'm actually representing the sixth term in that sequence. So if I have this sequence, 2, 4, 6, 8, we're counting by 2s. The initial value, the PO, is the 2. That's the first term. And PO is also called the initial value. And then you go from there. So P1, P2, P3, P4, P5, P6. But again, if I'm asking for the 7th term, I'm actually asking for the 14th. If I'm asking for P7, then I'm going PO, P1, 2, 3, 4, 5, 6, 7, which means that P7 is the 8th term or the 16th. But it's actually the 8th element in the sequence. So then we have 2 types of sequences that we're going to talk about, arithmetic and geometric. So our very first one is arithmetic, and think arithmetic. So with an arithmetic sequence, it's where you're adding or subtracting to get to the next term, and we're adding and subtracting what's called a fixed number. So to be an arithmetic sequence, we're adding 2 every time, or we're adding 1 every time. We're subtracting 5 every time. That number that we're adding or subtracting is called the common difference, and it's represented by the letter D. And it's the difference between any one term and the next. So if I go anywhere in the sequence, if it's arithmetic, to go from 17 to 21 is a difference of 4. To go from 5 to 1 is a difference of 4, and it should be 4 every time. So just quickly checking this, yes, 1 plus 4 is 5, plus 4, plus 4, plus 4, plus 4. So in this case, our D is our 4. So we're going to add 4 every time. So to really break this down, good, so we can see the whole thing. If we start with the initial value as 1, then P1 is that initial value plus 4, which gives me 5. So P1 is 5. So P3 is whatever P2 was plus 4. In this case, P2 was 9. So you add the 4 and you get the 13. So P3 is 13. So if I want P8, if I look at P7, P7 is going to be P6 plus 4. P7 is going to be P6, which was the 25, plus 4, which is 29. So P7 is 29, and then we're going to do this one more time. P8 is P7 plus 4. So P8 is the 29 plus 4, which is 33. So P8 is 33. Do you have to do all that every time? No, you could write out them pretty quickly. You could come over and say, okay, after 25, I have 28. Or sorry, 29, and I have 33. So just make sure you're following the pattern. So how I wrote this was with a recursive formula. So what a recursive formula is it uses the previous term or the preceding term to get the next one. So that's the idea that P6 was P5, the previous term plus the difference. P4 was P3 plus the difference. So to get P1, I'm going to do the previous term plus the difference. To get P2, the previous term plus the difference. So our general recursive formula that you do want to make a note, you need to know these, is that to get any point, Pn, use the previous term, Pn minus 1, and then add the d to it. So Pn is the term you're looking for, and Pn minus 1 is the previous term, and d is your common difference. If d is negative, it means you're subtracting, but you would see that in the actual pattern. All right, continuing on. I've got a couple of practice problems. So the idea would be you're going to stop and try these and then come back and look at the answers. So if you can, take a few minutes to try these out and see if you can get them. So I'm going to go over the answers though. So if the series is arithmetic, if the sequence is arithmetic, you can find D, and D would be the same for all. So to get D, take any two terms and subtract 1 minus its previous, and that's going to be my D. So 5, 5, 5, 5. So D is 5, and this is arithmetic. So we've got that part. And we can say yes. Then we want to find P8. So for P8, we're going to go ahead and put all these together. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this was P0, P1, 2, 3, 4, 5, 6, 7, 8. So P8 is 90, and I get that by adding 5 every single time. And 90 is also the 9th term. P8 means it's 8 iterations. Okay, for our next one, if the sequence is arithmetic, again, we'll be able to find that common difference. So I'm going to go right here. 10 to 13 is 3. So plus 3 plus 4. So this one is not arithmetic, and you would stop. We don't know the pattern from here because that's 3, 4, 3, 3. We don't really know what's going to go next. There's no consistency. So therefore, this is not an arithmetic sequence, and we would not continue on with it. Okay, I'm trying to scroll down. So for question 3 then, find the first 6 terms, and now we're given this information. So this tells us that PO is 30. So we're going to start with 30. And then we're going to add 2 every time until we get 6 terms. So add 2, add 2, add 2, add 2, add 2, 1, 2, 3, 4, 5, 6. So there you go. We'll type all those in. Now here's an example of one that's subtraction. So if my PO is 60, I want the first 6 terms. So I'm going to minus 3. Minus 3. Minus 3. minus 3 until I get down to 6 terms. 1, 2, 3, 4, 5, 6. So I am there. So that's my answer for question 4. All right, so things to take away from this one. You do want to know that recursive formula for arithmetic. So it's any term is the previous one plus that D. So you do want to make sure you know that one. There are 4 total. All right, for your geometric sequence. So a geometric sequence is one where you multiply by a fixed number or a constant. Now, if it's division, you're actually still going to multiply, but you're multiplying by a fraction. So how to get your number that you're multiplying by is take any one term and divide it by the previous. And this number is called your ratio or your R. And again, geometric is by multiplying. So if I take the sequence 5, 10, 20, 40, 80, 160. If I take 160, I would divide it by its previous, and that's my R. 5 times 2 is 10. 10 times 2 is 20, 40, 80, 160. So again, my R would be 2. So in that recursive format, if I want to get P1, I multiply the PO by 2. And if I want to get P2, I multiply P1 by 2, and so forth. So each time I'm multiplying by the previous number by 2. So if I want P6, P6 would be P5 times 2. Well, P5 was 160 times 2 is 320. So P6 is 320, which is also the 7th term. All right, so that recursive formula is that you can take it and you multiply it, the previous term, by your R. So for our practice problems, once you've determined that your sequence is geometric, we can then keep going. So in order to be geometric though, take any one term, not the first term. Where'd my pen go? I'm going to take my 125 and divide by the previous term, and that's your R. But always double check, times 5, times 5, times 5, times 5. So this is geometric, and R is 5. And what I have is PO, 1, 2, 3, 4. So I just need one more to get P5. So it's 625 times 5, which gives me 3125 as my P5 term. So then I'm going to go on to question 6. Determine if it's geometric. So I'm going to do 32 divided by 8, which gives me an R of 4. 2 times 4 is not 4. 4 divided by 2 is 2. 8 divided by 4 is 2. Then we went to 4. So this is a not geometric one. So you would not continue. So make sure that it's consistent the entire way through. Right? Then we phrase it a little differently. First term is 2048. And we're multiplying it by a half or 0.5, which means we're really going to make it smaller. So you would just plug this right in. 2048 times 0.5 gives me 1024. Multiply again, gives me 512, 256, 128, and 64. And again, that's 2048 times 0.5. And then you keep going. So hopefully that makes sense. So again, you want to know the recursive formulas for both arithmetic and geometric formulas. All right, next portion here is it works really well to get the first couple terms. But what if I wanted the 100th term? Are we really going to write out 100 terms? So let's instead think differently. we can actually define repeated addition as multiplication. So we're going to take a look at one of these sequences. We're going to look at that first one, 1, 5, 9, 13, 17, 21, 25. And we're back in the arithmetic. So we determined D was 4. So for PO, it was 1. For P1, it was 1 plus 4 was 5. For P2, it was the 5 plus 4 is 9, or it was the original plus 4 twice, which is 2 times 4. So I'm adding 4. I'm adding 4. I'm adding 4. So P3 is actually 3 times 4 because I'm adding it 3 times. Then I'm adding it 4 times on P4. 1, 2, 3, 4. So 4 times 4 plus 4 plus 4. So if it's P6, I've added the 4 6 times, giving me 6 times 4. So the 6 corresponds to how many times you've done the iteration or what that multiplication is going to look like. So if we take a look at this pattern, let me scroll it down a minute. To get that Pn term, so if I want P7, think about where this 6 was your 6, this 5 was your 5. That means that I'm taking my PO and adding that 4 7 times. So I'm taking the 1 and adding the 4 7 times, or 7 times 4, to get that P7, which was 29.
Hi, welcome to the arc. What can we help you with?
So if we continue with this same idea, then for our P15, instead of having to list out all 16 of the terms to get to P15, what we can do is just fill it in to that formula. So we're going to do 15 times our 4. Because we're adding 15 4 times. So we're going to take that initial value of 1 and add 60 to it, giving us P15 is equal to 61. So here's your next formula you want to make sure you know, and it's the explicit one. So explicit means we can get any term at any point as long as we know our initial value and what our D is. So instead of having to list them all out, we know our initial value, we know our difference, and whatever we're looking for. So if we're looking for P10, we put in 10 for N. If we're looking for P20, we put in 20 for N, so we don't have to go through writing out the entire sequence. So it's pretty useful. So you want to know the recursive and the explicit formulas for these. And I would just write them a couple times and kind of really get to know them. So right now would be a good time to pause and work through a couple of these. But just as a reminder, the Pn is equal to the initial value plus that D times N. So initial, common difference, and then N is whatever iteration we are looking for. So go ahead and pause and try a couple of these. So I'm going to go through the answers because you have the pause button. So if I want the 20th one, P20, I don't want to have to write out these iterations 20 times. My PO is 103. Then if I go through here, 3, 3, 3. So my D is 3. So knowing that, I can put it in. PO is 103, N is 20, and D is 3. So it gives me 103 plus 60, which is 163 for my answer. If I go to this one, again, I'm just double checking that it's arithmetic. Minus 3, minus 3, minus 3, minus 3. So I have PO is 42 and D is negative 3. And I want P12. So P12 is equal to PO plus N times negative 3, or 42 minus 36, which is 6. So if you have the formulas, it's a lot easier to find a lot of these. And a tip I do is I just write them at the top as I go. So that way I'm constantly writing them and I'm seeing them. All right, so when would you use which one? Recursive is really helpful if I'm looking for P1 and P2. In fact, this first one asked me for that. But then if I want to jump to P80, that is not going to be too helpful for the recursive formula. So we have this recursive formula here. There's my D, previous term plus 30, and I started with 120. So PO is 120. So P1 is 120 plus 30. And P2 is 150 plus 30 previous term. So there's the answer to A, 150 and 180. For the explicit formula, okay, we have D, it's 30. That's what we're adding every time. We have PO, it was the initial value. So for part B, PN is equal to 120 plus 30N. So for part C, P80 is equal to 120 plus 30 times 80, which is this nice big 2,520 for my answers. Okay, so think on that a minute, make sure it's making sense. And then try number 11, really pause it, try the same thing. So for question 11, we have a decreasing recursive, one pound in this case per week, minus 1. PO is 245. So we have 245. So P1 is 244 and P2 is 243. We're subtracting 1 each time. So for the recursive part, your P1 is your PO minus 1, and your P2 is your P1 minus 1. So that's how we get the 244 and the 243. For B, the explicit formula is PN equals PO plus DN. And if you write it enough, you really will start to remember it. PO is 245, D is minus 1. So I'm going to rewrite this as 245 minus N. And it's N times 1, but that negative in there is going to decrease us. 1 year. So after 1 year, she's losing per week. So we're going to say that 1 year is 52 weeks. So we're looking for P52. So it's going to be 245 minus 1 times N. So essentially 52 pounds lost in that 1 year, giving her 193 pounds as her answer. So again, make sure you can work through those. All right, so there's a couple more here. So our main ones that we're going to work with are arithmetic and geometric. But just so you are aware, other sequences exist. Sequences just mean that there's a pattern. Arithmetic is the same addition or subtraction. Geometric is the same multiplication or division. But if there's a pattern, we can still have other sequences. So one of them is called Fibonacci, and it's where you add the 2 terms prior to get the next term. So to get this 2, you add 1 plus 1 gives you the 2. To get to 3, you add the 1 and the 2 to get the 3. To get the 4th term, P4, which is the 5, you add 3 and 2. To get the 8, you add 5 and 3. To get the 13, 8 and 5, and so on. So again, it's a pattern. So it's worth just kind of noting, but it doesn't follow, necessarily any of ours. But if you know that it's Fibonacci, then you can do that. So this one says, looking at the sequence, it's a Fibonacci, because we go 5, 5 is 10, 5, 10 is 15. So the 2 successive terms are added to get the next one. So if we want P5, so this is PO, 1, 2, 3, 4, 5. So this one is going to be 10 plus 15, which is 25. And this one's going to be 15 plus 25, which is 40. So P5 is 40. Your infinite sequence, I was trying to move that up, is just where it goes forever. It's counting. So 1, 2, 3, 4, 5, 6, 7, 8, we just go on and on and on. Your alternating 0 and 1 is another one we sometimes see. 0, 1, 0, 1, 0, 1. Again, it's a pattern. We're not going to do much with it, but just so you know they do exist. You can have a sequence of consecutive odds. You can have a sequence of consecutive evens. So just note that all of those do exist. And when we say consecutive odds, it means the next couple odd numbers from your start. So it doesn't have to start at 1. It could start at 49. So if it started at 49, 51, 53, 55, how many does it want? 1, 2, 3, 4, 5, 6. Same here. If we start at 10 and we're doing evens, then it means just count your evens from wherever we're starting from. And you've got a couple of sequences there. So that is it for day 8. You have the day 8 assignment to turn in, and have a nice week.